All right. So what is NumPy? NumPy stands for Numeric Python or Numerical Python, and it's open source and it's a module for Python. It provides fast mathematical functions, and this is the ecosystem that completes machine learning using Python. So we learned Python already. We are comfortable with basic syntax of Python. Then we have pandas, NumPy, Matplot, TensorFlow, and scikit-learn. These parts are small libraries, while these are a little bigger libraries. Okay, so basically the most of these are just the modules and that we can use in order to achieve things. Just that these modules are larger and they have their nitty-gritties, and therefore we are learning individually these modules. Okay, if you are trying to do a web application, you're trying to build a web application like the way we have built CloudX Lab or something else, you could use Django. Django is another module for in Python. So Python has all kinds of modules, and we're going to go over the modules that are needed for data science, machine learning or analytics. Okay. NumPy provides you a big array. NumPy provides you a big array, which is extremely fast. And Pandas provides you a big table structure, which you can query. And Matplot provides you the ability to plot graphs. Scikit-learn provides you the machine learning algorithms, while TensorFlow provides you a way to do graph computation. Question from Kamal, what does the overlap of? What does overlap signify here? The overlap signifies that Matplot understands NumPy very well. Similarly, Pandas and NumPy are also overlapping, although in the diagram they are not. Scikit-learn heavily depend on NumPy as well as Pandas, and TensorFlow also depend on NumPy. So most of these systems, whether Scikit-learn, TensorFlow, all of these, they kind of assume that you have NumPy as well as you have Matplot. So while solving the problems, we will be using a combination of these. So the second session, just after the introduction of machine learning, what we are going to do is we are going to go over the entire case study of the machine learning first, and there you will notice that we use all of these components. Except for TensorFlow, we will use all of these components in a single shot. All right, so now let's face one important truth. Python programs are not very great when it comes to efficiency. The performance is not very great. But Python programs are sophisticated and easier to write, and therefore most of these libraries are available in Python, though these libraries are written in C. Most of these libraries are either written in C or C++. All right, let me just show you a quick example, and right. So let's try to understand the motivation behind the NumPy. I know that this is going to be something that we are doing before learning things. Okay, so here I'm just going to go ahead with something something that is not yet learned. So be with me. Trust me, doing things before learning them is generally better for learning. You will not be able to get the entire grasp, but you will get the general picture. Okay, so what I'm going to show you is the motivation behind NumPy. NumPy is nothing but a big list. Just like in Python, you have list. NumPy provides you this big list. The only advantage of NumPy is that this list is extremely fast as opposed to the usual Python. So NumPy provides you this big array or list on which you can operate, and it's extremely fast. Okay, let me show you how much efficient it is. Imagine that you had to do a multiplication of array, right? It's pretty simple. We could say I from range this to that, and we are writing our own operations. These are Python normal Python lists, A, B, and C, a normal Python list. Okay, and let's say we create these two functions. One is using this, other is the internal one. Okay, and now what we're going to do is we are going to initialize x and y, okay, and then call these functions. Okay, so you can see that I've just executed this time it, and when we use the multiply loop, it's taking close to half second. Okay, but if I use the numpy way of multiplying using the internal function, the method is extremely fast. So you can see that here it took around 28 milliseconds. If we use the internal function of numpy, and here it took 465 milliseconds. Okay, although both of these are numpy only, most of the parts are numpy, but if you do it further using the normal Python libraries, you will find the difference is really huge. Okay, so the point I was trying to show you is that using timeit, we could measure the performance of various things, and the NumPy's internal operators provided to you, NumPy's internal functions provided to you are far more efficient than the usual Python list. And therefore, for mathematical operators, for mathematical operations, we use NumPy instead of the default list. Okay? Okay, so you can see that the first function where we wrote the logic of multiplying things, it took around half a second, right? And when we use the internals, when we use the internal function, the this one using multiply vector, then it took 28 milliseconds. Okay, is that what you wanted to see, Binta? Do I need to zoom it? So there are two functions. One is using loops, and other is using this internal operators provided by NumPy, and this is what it is. So the point I'm trying to make is that I'm just trying to set the the motivation right. We use NumPy for performance, and NumPy, other than performance, the other thing what we use NumPy for is this wonderful set of library provided by NumPy, with which you can do a lot more on matrices. Okay, all right. Actually, I'm not showing the resulting output. It's basically multiplying two matrices. Don't worry if you have no clue about multiplying matrix. Don't worry. You just think of this as we are doing something complex, writing our own loops, as opposed to doing something using NumPy's internal operators. Okay. So all I did was I wrote timeit and called it here and said shift enter. And I'm not printing the result yet. Okay. At means here, at is an internal operator provided by NumPy for multiplying two matrices. Whatever we are doing here, the same thing is provided as an operator on by NumPy. We could the libraries could create their own operators on their objects. Okay, so-called operator overloading in the traditional languages. Okay, so this is what it is. So at is faster because it is implemented by NumPy. So NumPy is far more efficient. It is faster for two reasons. One, NumPy is written in C. The other reason why it's faster is because of various optimizations they have done on they have done um, on matrix multiplication algorithm. Okay, all right. So when we learn the machine learning, you will find that 90% of the algorithms are about matrix multiplication. Matrix multiplication. We will learn matrix multiplication soon. If not today, we will do it over the next week, and we will get a clear picture of what it means by set of equations, how to solve them, how to use machine learning techniques to solve those set of equations, and we will learn that part as part of linear algebra. Although mathematics is kind of good to know, but not too detailed mathematics is generally required because most of the core algorithms are available for everyone. So, so mathematics is good to know, but that does not mean that that should stop you from learning machine learning. Because earlier when people were learning algorithms, people thought that you need to know a lot of maths, right? That's why if you take a look at the book called DE Nuth, half of the book is mathematics. Half of the book of DE Nuth, Nuth is kind of the biggest piece of work. And so earlier when people were learning algorithms or normal programming, people thought that one must learn the mathematics first. And same is the scenario with machine learning, that it's a new field, and since it's a new field, and therefore we should all learn the maths first. But that's not true. That's not true. Once you get the hang of data, once you get the hang of how to use various algorithms, you don't need to know exact semantics of algorithm. Okay, and you should be able to utilize existing algorithms. Okay, but if you are creating your own algorithm, machine learning algorithm, then you might need to know maths. All right, but we are going to go over linear algebra quickly, how much ever is required. A question from a question from Noor is, so all these libraries are here to support machine learning, but do we have to know the theory and philosophy about machine learning? Of course, of course. We are going to do that on December 3 IST and December 2 PST. Okay, same time. All right, great, great. So I just wanted to show you this part. All right. And also those who are really impatient, they can try plotting the graph using plot. Okay, where did my plot go? Okay, so here let's say we are saying plot.scatter, and all right, so what we can do is from let me try writing this piece of code. Okay, plt dot plot 1 2 3 4. It should work, I think. You can see that I just drew a line. Good. So we are able to quickly plot things using Matplot. You could give it a shot. It's really, really smooth and easy. Okay, so you could give the values, let's say here, and let me put it the other way: 4, 3, 2, and 1. Okay, let's see how it looks. So you can see 4, 3. Oh, this is supposed to be 2. 4, 3, 2, and 1. So we can plot the graph really quickly using this library. Okay, so we are using the pyplot, and that's pretty much. All right, so using the Matplot library, we are able to plot all kinds of graphs, and we will use that more and more. Like here, we are trying to plot this complex graph with all kinds of parameters, and let me just show you plt.show. Okay, so we can plot many graphs as well. So we could actually plot multiple graphs together, and so experiment with this, and this should be good. Okay. What happened? It did not go up. I think there is a way to do a multiplot. All right, we'll go into these details as and when required. But Matplotlib is what we're going to use to plot the graph, because when we look at the graph, it kind of makes more sense of the data to us. All right, so we talked about two things. Numpy is an external library which is really efficient, and we're going to learn that part. Second thing we talked about is the Matplot, which is really fast library. All right, so we're going to go through the theory part a little faster and practical a little more. So NumPy provides you the array-oriented computing. It efficiently implemented multi-dimensional arrays, okay, and it's designed for scientific computation. It's library of high-level mathematical functions. Okay, I think okay. All right, never mind. I'll just show it from here. This is far better. All right, so okay, NumPy's main object is homogeneous multidimensional array. What does it mean? It means it's you can only have one kind of data in NumPy, and you unlike Python's list, which are really flexible and you could put any kind of things in it. In case of NumPy, you can only have single data type. And multidimensional array means you can have array within an array. So it is a table of elements, usually numbers, and all are of the same data type, indexed by a tuple of positive integers. And in NumPy, dimensions are called accesses, and the numbers are called the number of accesses is called rank. Okay, so this will make more sense to you. Imagine that you have this kind of array of arrays or list of lists. You can see that there is a square bracket here, there's a square bracket here. This is a list, this is a list, this is a list, and this is big list. Okay, so it is a list of lists. This is array of arrays. And in case of NumPy, we call that the first dimension or the axis and the second dimension. So first dimension is this one. How many elements does it have? 4, right? That means the length of this one is 4. And how many elements does this one have? 3, right? 1. How many rows does it have? 1, 2, and 3, right? There are 3 rows, 4 columns, correct? There are 3 rows and 4 columns. That means it's a 3 by 4 array. It's a 3 by 4 what do you call table. So basically it's a 3 by 4 matrix. It's also called matrix. The tabular form is also called matrix. It's a 3 by 4 matrix, and since there are total number of axes are 2, one x-axis, other is y-axis, therefore its rank is 2. Okay, had there been some z-axis also, imagine that there were 3 square brackets here, then it would be a three-dimensional array. Okay, the rank will be 3. Now, it's really, really easy to create NumPy arrays. I'm going to show you in Jupyter. Okay, and where is that? In the same folder that we have been working with, in the same folder, you will find that there is a there is notebook called NumPy. Not this one, not this one. This one is, I think, empty. Let me just check what is there in this. Yeah, this one is kind of empty. So, all right. So let me just delete it before. Okay, so let me also commit these changes. Okay, so yes. All right, so I've deleted that extra one, and now there is only this Python NumPy. Okay, in this, almost everything is there. To get started with NumPy is pretty simple. You can just say import NumPy, or you could say NumPy as NP so that it becomes easier. Yes, I have done that. I pushed the latest code with that. Thanks. Okay, now that's it. Now we are able to import NumPy. All right. Now to create a NumPy array, what we have to say is NumPy, which is NP here. We are saying NP. If we say this, then we'll have to write everywhere NumPy. Okay, like this. So we can use the as keyword as part of the module, and we could import that. So you can see the type of A. A is basically ND array, meaning n-dimensional array is the data type of this. So array method of NumPy module creates this. NumPy module creates this array, right? We can take a look at what it looks like, and you can see that it is pretty simple. Okay, now similarly, we can define another variable. Also, if you want to just fill up, if you want to fill up a particular, we want to create a array filled with zeros, and we want 3 to 4 dimension, meaning 3 by 4 dimension. 3 is the number of rows, and 4 is the number of columns. Then we could say np dot zeros, and please notice this is a tuple. This is a tuple here. Okay, and let me also show you how does it look. So you can see that it has created an array X with 4 columns and 3 rows. So what's the rank of this one? The rank of this one is 2, because there are 2 dimensions, right? In one dimension there are 3 elements, and each element is 4 length. So you can see that this is the shape of the array. Okay, now we could fill NP once, meaning if you want to create a fresh array with only ones, then we could use this. Okay, and those who are wondering what happens in case we create an array with say 3 dimensions. Okay, let's say I define 2 by 3 by 4. Now you can see that this is 1, this is 2, right? So you can see that this is a 3-dimension array. And I think x dot rank is there. No, x dot rank is not there. X dot shape is there. Okay. So basically, using zeros method, you could create a fresh new array filled with zeros. With np1, you could create a fresh new array with all filled with 1. Also, by default, the data type of this one is int 16. Okay. And we could change the data type, or we could actually um, not change, we could create, we could explicitly define the data type of our choice. Okay. So we could change this to say float 16, float 64, and that way it'll create an um, array with the different data type. Okay, so you can see that. All right. So what we are trying to do, we are trying to create an array filled with zeros or ones. Both filling with zeros and ones is very common. Therefore, they have provided a function which does that for us. But there is another method called full. What does full do? It creates an array filled with a particular value. Okay, filled with a particular value. So you can see that it has created an array filled with 0.11. Okay, filled with 0.11. Similarly, we could also create our array filled with, say, I think there is something called np.py. It's not there. Okay. Yeah. So if you want to create a 3 by 4 matrix, 3 rows and 4 columns filled with pi, then we could do this. Okay. So now, just like we had range in Python, you remember the for loop where we used a function called range to generate all the numbers starting at some point till the end, right? We could also do same in case of the NumPy. Using NumPy arange, what it does is it starts at a point, the first argument, till this value, but not including this value, and with a gap of third argument. Okay, so if you do not provide this, it is going to create an array with 1 as the difference, but up to 30, but not including 30. Okay, so if we say 6 here is going to go up to 28, but not beyond it. Got it? So arange generates the numbers starting at certain point till the second argument and with a gap of third argument. Okay, so start at 10 with a gap of 6, meaning 10, 6, 16, 16 plus 6 is 22, 22 plus 6 is 22, 28, and so on. So this range is basically generated by those three values. If we say 2 here, it will generate all the even numbers up to 30, but not including 30. Okay. All right. So the same is true with decimal number. Let's say we want to generate all the numbers starting from 0 up to 20, and we say at a gap of 0.1. You can see that so many numbers have been generated: 0, 0.1, 0.2, 0.3, 0.4. Okay. All right. So I hope that makes sense to you. So we can generate a sequence of numbers using this method called arrange. Okay. Now, a question to all of you is that if you are given this list, you see this one, what is the shape of it? What is the dimension? A question from Manoj is array and matrix are same? Yes. Array is basically array of elements and matrix is array of arrays. Okay. Matrix is more like a table of numbers. Okay. When I say shape, shape means the dimensions. Dimensions. What is the use of arrays and what can we do with it? A lot of mathematical operations can be done with arrays, and that's why arrays are predominantly used in machine learning. Okay, so the dimension, how many? This array has how many elements? One and two, right? That means 2 by, and this one, this element has how much? 1 and 2, right? Sorry, 1, 2, 3, 4. This array has 4 elements, right? So this means it is 2 by 4, and each this one has only one value. That means it is 2 by 4 by 1, right? Now, if you are given a normal list of lists in Python, we could create array out of it, saying np.array and pass x, okay? And then let's say, okay, so uh, we've just created xx with those details. So you can see that this is array of arrays. Okay, so the shape of this one is how much? This shape of this one is 2 by 4 by 1. Is it clear? How many elements does this array has? 1 and 2, correct? And the second one has how many? 1, 2, 3, 4, right? And how many does this one have? 1. So this is 2 by 4 by 1, correct? Everybody comfortable with this? Kamal? A question from Kamal is, what if it was not homogeneous? NumPy is going to throw an error on that. Try that. Because the objective is to make sure that all of the data types are same. And first it tries to upcast all the elements. If let's say you put one decimal and all of them are numbers, first it tries to upcast all of them to decimals. Okay. All right. And otherwise it throws an error or does something about it. Great. So a range creates this wonderful creates the sequence of numbers starting with given a starting point, an end point, and optionally the gap. Okay, and using shape attribute of the NumPy array, we can always check the the dimensions of matrix. All right, now let's say we would like to generate 50 numbers evenly spread between two numbers, right? Let's say we want to generate evenly spread out numbers, right? So here we are saying doing that. Let me take an easier example first. Okay, here is an easier example. Let's say between 1 to 100, we would like to generate the numbers with a gap of 10. Okay, so here, as opposed to the previous methods, here the 100 is included, and these are the numbers with a gap of 10. And what happens in case of 9? Okay, in case of 9, we have these. What about 8? No. And what about 11? Yes. So if we say 11, so what it did was it generated total 11 numbers, including 0 and 100. All right. So if we say between 1 and, so it basically generates the numbers evenly distributed between the two extremes. Okay. So between 0 and 100, if we say generate, say, or between 0 to 10, or say 1 to 10, 1 to 10, we want to generate 25 numbers. So it had generated these numbers. Okay. So using linear space, it would create these numbers evenly spread out. So what all we learned? We learned about the shape, we learned about the linear space, we learned about a range, and we learned that we can always create array using array function. We can convert any list of lists or any list of Python into NumPy array. Or using ones and full and using zeros, we could create these matrix full of that number, right? Those are the things that we learned. And of course, we can create a matrix filled with random numbers. This again is quite important when we learn further about matrix multiplication. We would be able to generate a matrix full of numbers. Here, full of random numbers means the number between 0 to 1. That is the random number. Okay, so here we are generating a matrix of two rows, right? Two rows, each having 3 columns, and all of the numbers are between 0 to 1. All of these numbers are between 0 to 1. Okay, so this is how these are some very cool methods that we could use. All right. So so we learned about all of this, and we can check the data size, and we can also use a method called item size in order to find the number of items. So say, for example, we are generating this C. C has how many elements? 1, 2, 3, 4. And the data type of C is 64-bit integer. And the size it's taking is basically 8. Okay. So it's an 8 byte. Each element is going to take 8 byte of space. That's what it means, right? Why 8 byte? Because 64 is essentially 8 into 8, which is 8 byte. 1 byte is 8 bits. Now, we can change the shape of one list into another. Imagine that we have created a simple list of numbers from 0 to 5, and we would like to convert it into 2 rows and 3 columns. So it's going to go up to 3 elements, put a break, and then create new record. Okay, so these elements went into the first row, and these ones went into the second. This is called reshaping an array. Okay, this is called reshaping an array. All right, so these are very handy methods that once we know that they exist, it will be very useful to know. Okay, also for the impatient, you can generally take a look at dir and np, and you'll see all kinds of methods there. Okay, you have abs, absolute, add, and so on. There are huge list of arrays. You have bitwise operators. You have all kinds of operators, methods available to you. Okay. Now, so we'll focus more on the concepts. Rest you can generally figure out, or we will learn whenever required. Okay. So here we are creating an array out of the Python list. Okay. And we can access an individual element just like usually we did. 0, 1, 2, 3. That means 19, right? That's what it is. It is in NumPy also, just like Python list, the arrays are accessed by using the index, and the index starts from 0. That means if I say 0 here, it's going to print 1. It's going to print 1. And if I say 1 here, it's going to print 5, right? 0, 1, 2, 3, 4, 5, like that. Okay, so the if you want to access a particular range, this is something unique about Python. And if you want to say, give me everything starting from 2, 0, 1, 2, up to 5. So 4, 5, right? 0, 1, 2, 3, 4, 5. Up to 5 meaning only till here. Just one element less than 5. Okay, so we get 3 up to 313. Okay, is it clear? I hope if the arrays were clear earlier. Right? The other cool thing is that we could also say, give me all the numbers starting at certain point, okay, till the end with a gap of 2. Okay, so starting at 2, 0, 1, 2, okay, with a gap of 2 meaning 1 and 2, that is 3 and 13, and then 3 again. Okay, so we can also quickly pick and choose the numbers by jumping the range. Okay, we are basically hopping between the numbers. Here if we say start at 2 and with a gap of 3, that means start at 2 with a gap of 3 means next number is going to be 7, right? And if we say -1, that means we will start from the back and go towards this side. Okay, so we'll start with 3, 13, and 3 and 1. That's what it means. Sorry, we'll start from here because the gap is only 1. So we'll start from 3, 7, 13, 19, 3, 5, 1. If we put 2, then it'll start jumping and it'll become 3, 13, 3, and 1, right? Is it clear to everyone? All right. So we could hop between numbers and reverse this array very easily. And this is a cool technique to reverse a array. Okay. Also, a very interesting part is that we could update a whole range of values in a single shot. So we could say a 1 to 3 and equals -1. That means this will become -1, this will become -1, and this will become -1. Sorry, this and this. 0, 0, 1, 2, yes, less than 3, correct? So a 1 to 3 is 5 and 3, right? And if I say equals -1, these two numbers are going to be updated with -1. Okay. So using this technique, you could update a range of values in a single shot. Okay. We could also say that update alternative numbers using this. So we could say jump by 2 numbers. Okay. Okay, jump by 2 numbers and update with -1. So you can see that starting from here, it got updated with -1, it got updated with -1, it got updated with -1, and it got updated with -1. Okay, and let's say what we want to say is starting from 1, okay, now update the rest with 0 with this. So you can see that these numbers now have been updated by 0. So this way you can always manipulate the array. Okay. All right. So we can update all values in a single shot. A question from Tanmoy is, why did 19 not change? Here 1 to 3 means 0, 0, 1, 2, not 3. The last range is never included. Correct? If you want to test, you can do that. Print A. See that? All right. So this way we could always update values and change a bunch of values in a single shot. All right. Then comes the, also please note that even if we assign this to another variable, this range, and then update that slice, the actual value will still get updated. For example, here we are creating a NumPy array. Okay, we are creating NumPy array and we are selecting a portion of it. Okay, so this slice is going to point to values from here to here, 0, 1, 2, 3, and up to here. No, I'm sorry, it starts with 1 till 4. So this is 1, 2, 3, 4, up to here, right? So we created a slice that points to this portion of the array, and we are saying update the first element of this slice. What is the first element of this slice? This is the first element, because a slice is going to look like this. This is going to look like this, right? So the first element of this one is going to be this, right? And hence, this, if we assign the first element of this will become 1000, and effectively this will also get updated. So that's why we are printing a, not a slice. So you can see that this value is updated with 1000. Yes. Thank you, Tanmay. Yes, that's what is happening. It's basically kind of pointer. So we are dealing with NumPy array. Okay. If you want to change some value and do not want to impact the parent one, in that case, you could use a method called copy. You could copy a portion of array and then keep changing it without having to update it. So another slice here has the older value, newer value, while the actual one remained unchanged. Okay, so this one is unchanged while this one got updated, right? Is it clear to everyone what it means? So we are basically uh, modifying the same array if we are operating on the portion of it. Okay. The reason why it is done is so that by default the performance remains intact. If we every time we do something, if there is a new matrix being created, the overall performance and the memory consumption will be too high. Okay. Now let's just create this X filled with 5 rows, each having 8 columns with random numbers. Okay. So if we say X1 is basically a array in itself. You can see that it's an array in itself. And if you want to access one, if you want to access say this particular value, we could say X11. Okay, we could say X11. X11 means 0, 1. This is wrong actually. Why it is happening that way? 0 is this, right? And no, this is an older value. Yeah, now it's correct. So we are saying 0, and 1. This is x1, right? This is x1. Now here when we say x1, we get this value. Either we could say x11 or we could say x1 like this, okay, or this. Both are same thing. You could access an element using either this or this. Okay, this one saves some more keystrokes. Instead of 2, you are just typing 1. Okay. Also, if you want to cut out a portion of this matrix, if we want to cut out a portion of this matrix, what does it mean by cut out? Let's say, let me just print it again. It doesn't. Let me make it a little smaller. Maybe this time it'll fit. No. So let me just make it 4 by 5. I hope that fits. Okay, this is good. So imagine that we had this matrix and we would like to cut out a portion of it, right? We want to cut out a portion of it. Let's say, let me just show you properly. Imagine that we have this matrix, and what we would like to do is we would like to access, say, a portion of this, right? We would like to just access this portion. Then in that case, we could use a mechanism like this one. We could use a mechanism like this one. We could say, give me rows ranging from this to this and this to this. Okay, so here what we are saying is, we are saying, give me these two rows 0 to 2, okay, and out of each column give me these ones. So what we are getting is, we are getting from here to here. Okay, let's check it out. So you can see that we got this, and we got this and this, right? So that's how we can cut a window from the actual matrix. Okay, so that's how we can actually slice a whole array. Okay, and here we are generating really huge array 5 by 5 by 5. How many elements? Quickly, who will tell me how many elements will be there in this X? How many random numbers? 125. That's right. So it's going to have 125 elements. Okay, so it's kind of a cube, or it's kind of cube, meaning every dimension is equal and there are so many numbers. So if we just want to take first two records from all, let's say this is first, so this from here to here is first, and then and so on. So you can figure it out, and we can do that in that case also. So we can take a small cube from a big cube easily. Okay, and of course you can select different dimensions here. All right, so we can cut out a piece of an array, piece of a matrix easily. Okay, also we can use the reshape function to quickly create a array. So here we are creating array of a matrix of 3 by 4, using reshape. So you can see that from 0 to 12, not including 12, we've converted that into a 3 by 4 matrix. 3 are the rows and the 4 other columns. All right, now what actually I want to show you is, let's say we would like to pick and choose certain rows. Let's say we would like to choose only first and second. So we create another array saying, putting tick marks here, that we want the first one, we don't want the second one, and we want the third one, by the way of saying true, false, true. That means the first row, which is this, will be kept, the second row will not be kept, and third row will be kept. Let me show you. So row is basically an array of booleans, right? The data type of this row on is basically boolean, right? It's basically it is essentially another array. Now, and this A, we know it already, that this is our list. So we are saying A rows on, and this is showing us these records, right? It's picking up this one, ignoring this one, and keeping this one. Okay. In the same way, we could also say that give me elements on the other side. Let me just see if it works. So I'm saying false, true, and false. All I'll do is I'll say np dot array. Okay, so it says that you cannot do that. Let me try with this other syntax. No, I can't do that. Why? 2 plus 2 is 4, and okay, I think I just need to put this inside a square bracket. Now you can see that. So it says true, false, true, false. Okay, what does it mean? Oh, looks like it doesn't work it this way. So this is okay. This I totally agree on. But if I just want to pick 2 from each side, probably I will have to say something like this. So true, false, true, false. No, it is not working that way. Okay, so we'll take a look at this again. So the point that we were trying to reach to is to select the rows based on a particular vector. We'll see the column selection soon. Let me undo everything that I was doing here. Okay, so yeah, this is okay. Now, this way we can do the row selection. Column selection, I don't think this is done this way. We'll try some more things. Also, we can do the additions on the matrix. Okay, we could do the additions like this. We are saying let's say we have A, which is from 20, 30, 40, 50. And then we have 4, which is 0, 1, 2, 3. That's how it will get generated. And we can just take a look at how does B look like. A looks like this, B looks like this, and C looks like this. Okay, so this is how it is. So this is an array, this is another array, and when we are adding, it's basically adding 20 to 1, 20 to 0, 30 to 1, 40 to 2, and 50 to 3. So this way we can add two arrays, and we can also subtract two arrays. Okay, we can also multiply two arrays. Okay, if we say A into B, it's basically element wise multiplication. 1 will get multiplied to 2, 1 will get multiplied to 0, 0 will get multiplied to 3, 1 will get multiplied to 4. And that's how we get the results. So you can see that it has multiplied, it has done the multiplication like this. Okay, just to give you an example, I have also done the manual multiplication. All right, so we could subtract, multiply the two arrays. We could slice it. We could fill it with zeros or ones. Okay, now there's something called a dot product. We could multiply. So we could multiply two matrices or two arrays using something called a dot product. Okay, what does it mean, dot product? Dot product means um, let's say we have these, so we'll first multiply this with this, okay, and so on. All right, let me just see if I can demonstrate in a better example. Dot products are very important things. For now, let's just assume that dot products are really useful. We are going to go into details like where do we use dot product between two matrices. Okay, a question from Kamal. What if the two arrays are not identical? We're going to cover that part as part of broadcast. Okay. And all right, so let me just show you what it means by okay, let me just show you what it means by a dot product. Okay, now I'm trying to pick these values. All right, so imagine that there are these two matrices, and what we want to do is we would like to multiply these using dot product. Okay, we call it dot product, and the way it happens is we take these two values. How do you? So we take this, multiply with this, okay, and sum up all the values. That means it'll become 1 plus 1 into 2, okay, plus 1 into 2 plus 1 into 3. So this value multiplied by 2, this value multiplied by 3. Okay. So that becomes our new value. Okay, so I'm going to put it like this. Now, the second thing that we're going to do is same thing we're going to now multiply with this. Okay. So now we're going to multiply this with this. Okay, so and this. Okay, I'm just trying to see that if it doesn't select. Okay, never mind. So now this is going to be multiplied here, so it'll become 1 multiplied by 0 plus 1 multiplied by 4. Okay, let me pull it a little bit more. Okay, so we basically are multiplying two arrays. Noor, don't worry. I'll take you through the course as we go ahead. Right now, we are just multiplying these two. Okay, And it's pretty simple. It's pretty simple. So you don't need to learn it from somewhere. Let me just explain again. So let's say we have 2 by 2 matrices. This one is one, this is another. So row of first one multiplied by the column of the second one. So 1 into 2 plus 1 into 3. That becomes the first element. Now the same thing is going to happen here. 1 into 0, 1 into 4. Add it. And this is what it means by dot product. Now the same thing we are going to do with this and this, which is 2 into 0. Okay, 2 into 0. All right. 2 into 0 plus 1 into 3. Okay, so 1 into 3. All right. In the same way, what we're going to do is take this row, multiply with this column. So 0 into 0, 1 into 4. Okay. 0 into 0, 1 into 4. All right. That's what is the dot product. All right. It's pretty simple. Is it clear to everyone? Noor? So we are multiplying, we are doing the multiplication of these two arrays. It's pretty simple. Take the row of first one, multiply with the column of the second one, and so on. Okay. And that's what I'm trying to demonstrate here. And the good part is that we don't need to learn it. The NumPy does the dot product for us. Okay, you can see that NumPy has done the dot product exactly the way we have done. Okay, so all we need to do is np dot dot. All right, so looks like we have again run out of time, and never mind. So I think we have still one more day left, and we can plan one more session. So I think this is very much required. So we can just plan for like a 2-hour session on the coming Saturday. Okay, December 2 for us, and we can complete the pandas and the numpy in that session. Okay. Okay, we'll just go with our usual session. Thank you, Kamal. We'll just go with the three hours itself, and in case there are more questions, we can keep it maybe in the December 3rd second half. Okay. All right, so good. I think 3 hours will be sufficient for covering the pandas and NumPy. Okay, so NumPy is good enough. You all must give it a try to this particular worksheet. Okay, you must give it a try to this particular worksheet. It is available in the same folder, the one that I shared with all of you. In the same folder, it is available. All right. Don't get intimidated by the maths. It is pretty simple and you can easily handle it. Okay. So here is the link for the GitHub repository. A question from Noor: will we work on practical examples of machine learning use case? Yes, except for this initial part where we are trying to learn to walk, with the basic tools. Except for these, everything is going to be very much use case oriented. We will start with the use case and then we'll walk backwards. And that's the only way we're going to conduct rest of the course. Okay. So after December 3, everything is going to be use case oriented. Okay, use case oriented. We will start with the use case and we will walk backwards and then utilize all the tools and techniques that we are learning in order to solve a problem. Okay, so those who are planning to go with the full course, they can go to the main site, CloudX Lab. Okay, and you know, go to the machine learning specialization and you can enroll for the course. If this in this course, they're basically Python for machine learning, which is free, and machine learning and deep learning. If you are only interested in machine learning, not deep learning, you can enroll for this one. Otherwise, you can also enroll for deep learning. But I would strongly recommend that take up the entire machine learning specialization. This way, we are going to work together in order to solve one problem per chapter and learn the entire machine learning end to end. This is probably the most hands-on course, and it's a pretty big course. And 1/3 we have already finished, and 2/3 is only left. Okay. All right. Thank you, everyone. Bye bye. Have a good day.